Okay, welcome to today's Vancast, Monday. Okay, just keep in mind, these have to be not too slow because the file gets too big and also it just takes too long. Okay, so you're expected to rewind to stuff. Okay, today's assignment will be on Teams. Pretty simple one, I think. All right, so now I'm just going to go over some points from the last assignment on biomes and the graphs and net primary productivity and gross primary productivity, and then go over a PowerPoint. I hope that doesn't take longer than 5 minutes. It's on energy flow and ecosystems. It's really good. It's in the OneNote biosphere section. Okay, so I just kind of realized an easy way to understand GPP, gross primary productivity, is an analogy of how much food we eat. Okay, how come we don't gain weight? Well, it's because a lot of the food, most of the food we eat, is used to produce heat. Okay, and produce energy, and that's called respiration. So that's why most of the food we eat doesn't turn into body weight. Okay, so most of the food you eat is almost all the food you eat, essentially whatever doesn't get used, which is very little. That's gross primary productivity, all the energy that you use. And the rest of the food you eat becomes body tissue, which is not a lot of all you eat, right? So that's referred to as net primary productivity, NPP, or biomass, very common words in the ecology world. Okay, so respiration uses most of all your energy. And then net primary productivity just uses some of it, which becomes tissue. So GPP equals NPP plus respiration. Ecologists do use that. Okay, so hopefully it makes sense. So now I'm going to go to referring to the last assignments, biomes, and 9 graphs. I did an explanation in Teams about it that was okay, I think. I gave you an NPP, GPP explanation there. And then understanding that NPP, or biomass, is someone's weight. I think I had a question about what is your NPP, which is just your weight. And then I had you guys go to OneNote and refer to these maps here. Okay, and I put in underneath here that the red line is temperature and the blue area is monthly rain, monthly precipitation, even though I put yearly, which was wrong. Okay, so I'm going to go to OneNote. I had you guys go to the OneNote notes section, biosphere notes section. And here it is. So the first 3 were with deserts. Second 3 are grasslands. Last 3 are forests. And the big difference to be noticed is the blue area, the amount of precipitation per month. That's really the big difference there. Okay. And here for the deserts, there's a lot less precipitation. Okay, the blue area. There. And then I asked about wet season and dry season. So if there's one area of the blue that has a significantly more precipitation, that would be a wet season. So here, there's hardly a wet season, but there's a little bit of a wet season here in winter, assuming actually that's the northern hemisphere, sorry. So we have a wet season here and here. These go together, so that would be November to March. Here, maybe, can't really say. Here, distinctively in this tropical grassland, you have a wet season. Okay, these months in the blue area. Here, a bit of a wet season. Not much of a wet season here. Here we're getting a big wet season. These 2 blue areas. Here, not much of a wet season. Temperate deciduous forest, no wet season. And maybe a bit of a wet season. What are we? We do have a wet season. We would be in between we're a savanna, Everglades actually, not us. We're deciduous forest. Sorry. So anyway, the Everglades has a distinctive wet season, just like a savanna, tropical savanna. Okay, so I'm going to move on. How much time have I used here? 5 minutes. Okay. So we're gonna move on to the OneNote. This is on OneNote Biosphere section. On the top of Biosphere section, we have a lot of good stuff to refer to. Here in the very top is the syllabus, points for the syllabus. I made a mind map for these to kind of help you somewhat distinguish it, but there's a lot of stuff on the mind map, so I want to go back to that later when you have more of a sense of what you're looking at. And then these are really good videos and what's in them from Bozeman Science. And here's a little with the Bozeman Science, but with the mind maps for them. Okay, and these are also for human population, and we are now using this one here. We're looking at this one, PowerPoint, Energy Flow and Ecosystems. Okay, these are very good PowerPoints there. I got these from a well-established ACE environmental teacher. Okay, so I'm going to go to that PowerPoint. This PowerPoint, it covers nutrient cycling, trophic energy levels, GPP, limiting factors, productivity. We're not going to go through all of them, but I'm going to go through at least the first 18. Okay, so this is ecosystem. I don't want to spend too much. I have specifically one I want to get to. Okay, so this is nutrient cycling. Very simple. Living stuff dies and then gets decomposed and then gets taken up again by plants and planktonic kind of things that have photosynthesis, bacteria that have photosynthesis. So it's really simple. That is not difficult. It's just soil production, really. Okay, so we'll get to that a little more later. Community, we've talked about. I'm not worried about that. Niche. Trophic levels, we've talked about these. Okay, a general rule, 10, the rule of 10. Very, very roughly, this energy available to be eaten, the biomass, can only turn into 10% of the above biomass. So roughly 10% of what you eat turns into tissue, living tissue available to the next trophic level. Plants are good at more efficient. They can turn half of the sun's energy into biomass. Actually, they can. And solar energy is trying to copy that. Anyway, so that's that slide about trophic levels. This is again chemical cycling, and it's just stuff dies and it gets processed in the soil, basically bacteria, fungus, all kinds of stuff. And so that's all it is. Carbon cycle, nitrogen cycle. Everything dies and gets broken down and gets taken up again by plants and other photosynthesizers. Okay, this is the GPP. This is using energy, as I already explained, so it's a little more complicated, but it shows part of the energy taken in, the food taken in by organisms or energy goes away as heat. Okay, this is the trophic levels. Only 10% is available to go up. Of all the energy they take in, only 10% will go up, because only 10% of all the energy an animal or an organism uses becomes tissue available to be eaten by the next trophic level. There's the 10% rule. J is joules or energy. So if they're using J, this would be considered gross primary productivity, GPP. But if you replace it with biomass, body tissue, it's really no different. producers. Only 1% of sunlight is used by photosynthesis, but still that's plenty, more than enough. And then this has to do with limiting factors we'll get back to. So if a system in the soil, basically in the nutrient cycling, if there's only phosphorus and no nitrogen, you'll only get this much growth. This is the biomass, the amount of stuff above ground. If there's only nitrogen in the soil, or whatever this experiment was, and no phosphorus, you get this much growth. If you have nitrogen and phosphorus together, you'll get even more growth. So these not here having nitrogen but no phosphorus, that means phosphorus was a limiting factor. It needed more phosphorus. It could not grow more. And here it has phosphorus, so nitrogen was a limiting factor. It could not grow more without it needed nitrogen, assuming everything else is okay in the experiment. Okay, energy available, so more primary productivity. And this is the same thing, get energy from the sun. This is the energy it uses, okay? And then some becomes heat and respiration, most of it, and then some of it becomes biomass, NPP, available for the next level. Plants have a high efficiency. As I said, they're trying to copy that for solar power. Okay, and primary productivity varies depending on, these can be limiting factors. Amount of CO2 in the air can be a limiting factor. The amount of light, obviously, is a limiting factor. Minerals available in the soil, we just mentioned nitrogen and phosphorus especially, can be a limiting factor. A little funny aside, when they first started ranching cows in Central Florida, after a while, a couple years, cows started just becoming weak and skinny and dying, and the limiting factor for cow production was copper in the soil. The copper would just get leached down away with the sandy soil and the rain, and the cows couldn't, well, they were dying, but they figured it out and they fixed that. Amount of water always is a limiting factor, huge factor, huge. And temperature, so those are climate, those are massive abiotic factors, and they affect biomes, what kind of biomes we have. Okay, what's the time like? Oh my gosh, 12 minutes? Oh my gosh, that's crazy. Okay, so this is productivity, this is the amount of carbon, some satellite image. And you can see where it's wetter along the equator and warmer, and especially the water, and you get more productivity. And then here, the 30-degree level zone, the deserts, you get less productivity. That has to do with water. This is the ocean productivity. And this one, blue, was actually, no, green was more productive. So, and then they get into different biomes. So, and when they're talking about GPP or NPP, less biomass in deserts, obviously, and more biomass in forests. That's low NPP, high NPP. Okay, that is 18. I wanted to go to number 18. And B, this graph is what we care about. Average net primary productivity. See, grams per meter square per year. So that's grams, that's weight. That is biomass. And you can see algal beds are the most productive. So algae is really efficient. In reefs, the algae is the primary producer. Algae and corals, they work, they're symbiotic with coral polyps. So that's quite something. And then, as can be expected, tropical rainforests are very productive. Mangroves, I always want to see mangroves because mangroves are extremely productive. So it says swamp and marsh there. And that should be it. And then it goes into some nice different biomes. Okay, that's it for now. Hope it's not too long. I'm sure I'll get feedback on that. Come on here. Stop. Where is it? Oh boy. Oh my goodness.